Welcome to our review of area between two curves, volume with discs and volume with washers. So it's going to go in that order. We'll have some of each problem and there'll be varying difficulties on each problem. I'm going to start with area between two curves. On each of these problems, I'm going to sketch the graph first. You may not necessarily need to sketch the graph for all of these, depending on who your teacher is and whether or not they want you to, but we're going to go ahead and do that because it makes it easier to check and make sure that we know which function goes first and things like that. Because for area between two curves, one of the most important things for us to do is to make sure that when we're integrating, we put the top function first and we subtract the bottom function. It's a pretty big deal that we do that, top minus bottom. And so if we haven't graphed it, we may not know which is the top and which is the bottom. Now we are on number 1. I've already got the lines that we need. Y equals 2 is a horizontal line at 2. X equals -3 is a vertical line at -3. X equals -1 is a vertical line at -1. The only thing I have left to graph is 2 over x squared. I went ahead and graphed the lines because it's hard to draw straight lines on a tablet with your computer. Or at least I was having some issues with it. So I've gotten better, but I just thought I'd knock out the straight lines with the handy dandy straight line tool. Now, to graph 2 over x squared, you either need to plug into y equals and look at the table of values as well as the graph to see what's happening, or if you're not allowed to use your calculator for some reason, you would plug in numbers for x to figure out what the y values are that go with it. And it's really not that hard to do on this one. Like, you can pick -1 since we know that we want to be over here where all of our lines are. When I plug in -1, I get 2. When I plug in -2, I do 2 over -2 squared and get a half, and so that means it's down here. And then if I have knowledge about 2 over x squared, or if I'm looking at my graphing calculator, I know that this should go down and to the left towards 0, up and to the right towards 0 this way. And then we want to shade between y equals 2 and 2 over x squared. In between also -3 and -1, and so that is this part right here inside. And so that is our shaded region. This is where we're trying to find the area of, is this part inside that I'm shading right now. And so one of the things is, what is making up the top of this region and what is making up the bottom of this region? Well, the top of the region is made up by this line, y equals 2, and the bottom is the reciprocal function we have, the 2 over x squared. So whenever we set this up, the function that goes first is 2, and the function that goes second is 2 over x squared. Then we need boundaries for our area, and so they actually gave them to us. The -3 and the -1 is where we stop on either side. So we start at -3, we stop at -1. Your bounds on your integral are always the bottom number is the number that's farther left, and the top number is the number that's farther right. Depending on whether they're positive or negative, you can think of it like the top number is the bigger number, the bottom number is the smaller number. But when you deal with negatives, that makes things kind of weird. So we want to integrate this, and both of these things require us to use the power rule. And since we're going to use the power rule, this 2 over x squared we really want to think of as 2x to the -2, or even -2x to -2 since we're subtracting. And so when I add a power and divide, I get -2x to the -1. Make sure when you add a power to a negative that you realize it gets less negative, not more negative. And then we have to divide by our exponent, which is -1. So that's going to give us, for our next step, the integral of 2 is 2x. The integral of -2 over x squared is this right here, but we're going to simplify the negatives, which gives us a plus in between. And we can move the x down to the bottom, or if we're going to plug into our calculator, we don't really need to move the x down to the bottom. So this is going to be 2 over x, because the 2 stays on top, the x moves down to the bottom, and the negatives cancel. We are plugging in -1 and -3. The way this works is you plug in the top number first, and then you subtract, and you plug in the second number next. So this is going to be 2 times -1 plus 2 over -1. So I plugged in -1 to both places, minus, we're going to do 2 times -3 plus 2 over -3. Now, if we work this out We have different ways we can do this, like we can do this in our calculator, or we can do this by hand. And so depending on whether or not you're allowed to use your calculator would be your approach. If you have to do it by hand, there is a part over here that's like a common denominator situation. However you do it, and I'm not gonna bore you with the details, you should get 8/3, which is approximately 2.667 for your answer. So whichever way you want to do that. If you plug it in and you're not getting 8/3, you're doing something wrong when you plug it in. Make sure that you are using order of operations correctly and putting parentheses in the correct spot and things like that. So 8/3 is our answer on that one. Now let's do another one. This time we're given 0 and 4 as our boundaries on the left and the right side. So that'll be the boundaries of our integral. Then we need to graph square root of x and 3 square roots of x. And so if you're doing this by hand, those actually probably aren't as bad as you might think. If you're doing them in the calculator, just plug it into y equals and then look at your table of values. Both of these actually start at 0, 0. When I plug in 0, I get 0 from my square root. But when I do square root of x and I plug in 1, I get 1. The next number to plug in that would be a nice number would be 4. The square root of 4 is 2. And that gives me all the points that will fit on this first function. When I do 3 square roots of x, it starts at 0. But when I plug in 1, I get 3 because I do 1 times 3. When I plug in 4, I square root that and get 2, but then times it by 3 and get 6. So that gives me a much taller, faster square root function than the first one. Now, if I wanted to shade in between these two curves as well as in between 0 and 4, that's this nice part right inside of here. That's what we're trying to find the area of. So we have to think about which part of this is making up the top and which part of this is making up the bottom. Well, the 3 square root of x is actually the top part of this, and the square root of x is the bottom part. So that's the order we want to do these in. 3 square roots of x minus the square root of x dx. There's 2 things we want to do here. First off, and it doesn't actually matter if you do this, but it will make you have less work in general. If you have 3 square roots of x and you subtract 1 square root of x, you have 2 square roots of x. So you don't have to combine the like terms there, but if you do, you'll end up doing less work. So if I think of that as 2 square roots of x, to use the power rule on this, I need to change the square root of x into its power. A square root of x is really like x to the 1/2. So this is 2x to the 1/2. That means that when I do the power rule and add a power and divide, I'm really going to have to add 2 over 2, because that's adding 1 to a half. It gives me 1.5, but then that makes things more difficult to think of it that way. So I need a common denominator. That gives me an exponent of 3/2. And don't forget with the power rule that you divide by what you get for your exponent. So this is 2x to the 3/2 over 3/2, and we're evaluating it at 4 and 0. Now you can actually do this exactly the way it's written in your calculator. 2 times 4 to the 3/2 over 3/2. And then you can do the same thing with 0, but you should get 0 because 0 to any power is 0, and then it just makes the rest of it 0. The other thing though is if you don't have your calculator, or if you want to do this or understand what's happening here, when you divide by 3/2, you're going to be multiplying by the reciprocal. So that gives us 4/3 because of the 2 that's already on top. And when I do 4 to the 3/2, what I'm really doing is the square root of 4 cubed. And it doesn't matter whether you square root it or cube it first. We're just going to have to do both of those things. Again, if you're plugging in the calculator, it doesn't really matter. But if you're doing it by hand, you'd square root 4 and get 2, and then cube it and get 8. 8 times 4 is 32 over 3, which gives us our answer, which is 32 over 3. Or as a decimal, that would be 10.667. So that's our answer. Number 3. Now this time we don't have any boundaries, and so when we graph this, what our boundaries will be are intersection points. And so of the two of these, the easier one to graph would be negative x plus 1 because it's a line. It starts at 1 and then has a negative slope. And we don't really have to draw like all these points, but it may help us to be precise. It may make it easier for us to find where they intersect. If we didn't want to graph it, but we wanted to know where they intersect, we could set these equal to each other, these equations equal to each other, and solve for x. That would be another way to do it. But if we graph it and we graph it well, we should be able to tell where they're intersecting. So when I graph this, I get that my vertex for my parabola is at 3, 0. And then it goes down 1 each direction. And then it goes down some more to 1, negative 4, and 5, negative 4, which helps us find our next intersection point. If we look at this, it goes through our line at 2 nice places. And that doesn't always necessarily have to be the case. Depends on, you know, how nice or mean your teacher is, maybe, as far as, or how much they're paying attention. If they just make up a problem, they could accidentally make up one that doesn't intersect nicely. So what we want to do is find the area of this shaded region. The top of the region is made up of the parabola. The bottom of it is made up of the line. If you're confused about how I know that, like, look at it. What is on top of this region? Is it the line or the parabola? It's the parabola. The other thing we need is our intersection points, and we only want the x values. We are not worried at all about what the y values are for our points of intersection. So here's one of our points of intersection, which is at 2. Here's the other one, which is at 5. So we're going from 2 to 5. Our first function is our parabola. And then we're going to subtract our line. And the thing that is important here when we subtract the line is that we have to distribute that negative. And so what that does is it makes this be, I've lost my cursor. Okay, I found it, don't worry. It makes this be plus, plus, minus. When I distribute the negative, it changes both of these signs. And then I can add like terms. I don't have to add like terms, but it will make me have less math to do in the long run, which, hey, isn't that the goal in life, is to have less math to do? Not my goal. I love math, but maybe your goal. So we're going to do 6x plus x, which is 7x. Negative 9 minus 1 minus 10. Negative 9 plus a negative 1 is negative 10, not a positive 8. Don't know why anyone would think that. I definitely didn't do this whole problem thinking that that's what it was. We're going to power rule this now. So we're going to add a power and divide, which means that we will get negative x cubed over 3 plus 7x squared over 2 minus, we take that 10 and put an x with it. So we're evaluating it from 2 to 5. And this may be actually, even though it's a polynomial and it's relatively nice in some ways, or at least it started out nicer than our other problems that we've already done, this actually may be harder to find the answer to for some of us because it takes a lot of effort to plug this in and to plug it in correctly. Not as much as if we had negative numbers that we were plugging in, but still a decent amount of things could go wrong. So if we plug this in correctly, or if we decide to do this by hand, which either one is fine, you just have to know what's best for you and what your teacher wants you to do and that kind of thing. If we work this out, we should get 4.5 or 9/2 as our answer, which is a fairly nice answer actually. None of those pesky thirds or anything like that. So if you're not getting that and you're plugging it into your calculator, you need to go back and be extra careful and make sure that you're actually plugging it in correctly, either exactly the way it's written down, or if you're plugging it in by parts, make sure that you're not combining things that shouldn't be combined, or things like that. Here's another one that this is similar to the one we just did because our intersection points aren't given to us. We have to figure them out as we go. And so these are two parabolas. Let's see. The first one, x squared plus 8x plus 13, has a vertex at -4, -3. If you're not using your calculator, that's where you normally start. You can do -b/2a to find your vertex. So that's -8/2, which is -4, and then you have to plug it in to figure out what your y value is. Unfortunately, to graph parabolas by hand can really be frustrating. But because it's x squared, I'm going to go up and over 1 each, and then go up and over 3 more. And then I do need the next point, which is, let's see, that was -6. So -7,6, I believe, is the next place we've got. And so that is going to be one of the places it intersects, which is why we have to go all the way up there. Otherwise, I would have just probably been lazy and given it a rough finish. So that's our first one, the one with just x squared. Our next one has x squared over 2, which, just so you know, makes this wider. Our vertex for this one is at -3, -2, which is right here. So since it's wider, that means it only goes up a half right here, and then it only goes up 2 total from our vertex on either side here. And then we would go to like 4.5 up, so 1, 2, 3, 4.5. So like here. And then our last point is up here at this point of intersection, so which that actually would go on the other side anyway. If you're using your calculator, you can get there much faster and probably easier than if you're graphing it by hand. But what matters then is that inside of here is where we're shading, and depending on how well you draw your graph, you may accidentally make a mistake here. The point of intersection on the left side of this is the point that both of them had in common, which is this point here. The x value for that is -7. And then over here, the point they have in common is -3. So our integral is going to go from -7 to -3. We've got the wider parabola, which is in blue. That's the one on top in this case. And so if you graph it and you put it on your paper and then you're like, well, I don't remember which one was which. If you press the trace button, it'll put your cursor on, it should put it on y1. And so whatever you have entered first, it should have the cursor on. So we need to put in x squared over 2 plus 3x plus 5/2. That's our first function because it's on top. And then our other function is on bottom, so we're going to subtract it. Now this is going to give us an interesting set of simplification here, because we can do like terms once we've distributed that negative, but our like terms are a little unpleasant. X squared over 2 minus x squared. How do we subtract those? Well, this is like 1/2 minus 1, which is a -1/2. So this is -x squared over 2. The 3x minus 8x, because remember the negative gets distributed, is -5x. And then 5/2 minus 13 is the other thing we need to do. Let's see, 5/2 minus 13, that would be -21/2. And all we did there was add like terms, so we're not done with our integral yet. We have not yet used the power rule, so that's our next step, is the power rule. Now when I power rule -x squared over 2, I get -x cubed, but if I divide by 3, and I was already dividing by 2, those numbers both go on bottom, multiplied together, so that would be negative x cubed over 6. Then negative 5x turns into negative 5x squared over 2. Negative 21 halves is a number, so it needs an x. We're going to plug in negative 3 and negative 7. If you thought the last one was hard to plug in, just wait until this one, because this is potentially quite a bit trickier. We have a negative and then negative 3 cubed over 6 minus 5 negative 3 squared over 2 minus 21 halves times negative 3. If you are plugging this into the calculator, please put negatives in their own parentheses where the only thing in parentheses is negative 3. Where the only thing in parentheses is negative 7. Nothing else should be inside the parentheses. Not the power, not what's in front, not what's underneath. And that's probably one of the easiest mistakes to make on this, is to put the parentheses in the wrong spot, or not to put parentheses at all, because the parentheses are telling the calculator that you want to do negative 7 squared, which is a positive 49. If you don't put the parentheses there, then you're saying you want to do negative 7 squared, which is negative 49. It's the difference between what is this and what is this. And it may not look different to you, but it is. When I square this whole thing, I multiply two negatives together and get 49. Whenever I square this, I'm only squaring the 7, which is 49, and then making it negative because there's a negative in front. If you work this out correctly, either by hand or not by hand in your calculator, you should get 16/3, which is approximately 5.3 repeating. All right, so on number 5, we have area between two curves again. We've got two lines here to take care of. I'm just pulling up my review again so that I can see the graphs. Okay, so this is where we get into the having really interesting graphs that end up creating like two areas for us. And so y equals negative x starts at 0 and has a negative slope, so it goes down to the right and up to the left. And then for this other one, we've got a cubic function, so this is going to be pretty difficult to graph by hand. If you've got a calculator and can just plug it in, that's great. It does start at 0, 0, and then we've got a point at -1 comma like -1 point something, like it's somewhere down here, and then at -2 it's at 2, and so that's one of our intersection points. So we've got like this thing going on, so this is an area that we're going to care about. And then the other direction, it goes up really far. I'm not sure how accurate this graph I drew was. I know that it intersects at 4, -4 down here, and it ends up like going way up. On mine, I have it drawn up to like 6 and then coming back down. I don't know. I just missed that. I don't know how precise that is. If you're graphing it on your calculator, you might be like, well, that's not exactly it. But that's the gist of it. And if you were doing this by hand and didn't want to graph it, what you would care about is setting these equal to each other and solving so that you figure out these points where they intersect. There would be 3 answers for this. It intersects at -2, at 0, and at +4. And so because it intersects 3 different times, we're actually going to have to split this into 2 different integrals. So our first integral is this first area, -2 to 0. And we have to look at that and say what's on top and what's on bottom of that region. On top is the line, which is -x, and on bottom is the cubic function. But then we have another integral to do because we have this other area to worry about. And so it's from 0 to 4, which makes a difference. But also, now the cubic function's on top and the line's on bottom, so we have to switch that around and do -x cubed over 2 plus x squared plus 3x. That part's first, and then we have to minus -x second. What should happen if we combine like terms here and we distribute the negative correctly, is these should be exactly opposite of each other. So if I change these signs and then go ahead and put the negative x and the negative 3x together, what I end up with is x cubed over 2 minus x squared minus 4x. And then whenever I do that on the second one, from 0 to 4, this will change just to plus x, and so I have the exact opposite. I have negative x cubed over 2 and positive x squared and positive 4x. Now, the difference that makes is going to be significant, especially because we're also plugging in different numbers. We're not plugging in the same numbers into both of these, which is why we can't just combine them. You want to treat this kind of like two separate problems that then you add their answers together at the end. We need to power rule right now, so x to the 4th divided by 4, but there's already a 2 on bottom, so that's going to give us an 8 on the bottom, minus x cubed over 3 minus 4x squared over 2, which does simplify, and so you can either simplify it right there or wait until later, or not simplify at all actually if you really want to. And then, so we've got that going on that we're going to do, and then we're going to do, and this should again be the same thing but with opposite signs. So if you're working it out and you get something totally different the second time, that means you did something wrong one of the 2 times, and it's up to you to figure out which one. Fortunately for us, where they meet in the middle is 0, so that's actually going to make this pretty easy to, or easier to plug in, because when I plug 0 into all of these, I get 0. So all I really care about is plugging in negative 2. Make sure that you use parentheses appropriately here. This is really just 2, so minus 2 times negative 2 squared. Like I said, you don't have to actually simplify that at all if you don't want to. On the second part, the 4 goes in, and then when 0 goes in, that's 0. So this time you will have to put in a number for the first part, but then we'll minus 0. That was a close one. 4 times 4 squared. I didn't simplify on that one. You can simplify or not simplify. It's really whatever. So we employ this into our calculator, and if we do, we want to make sure that we're paying attention to negatives in parentheses. You can do it by hand, which there should be some things that are fairly easy to add together. But when all is said and done here, we should get an answer of 74/3, which is approximately 24.667. So that is our answer, 74/3, which is about 24.667. We've got one more that's like this on number 6. And so we're going to graph it. And this one's got a parabola and a cubic function. They both go through 0, 0. The parabola has a vertex of 2, -4. So we've got this kind of situation going on for our parabola. And then we will need to go all the way to 5, 5 for an intersection point. So here's our parabola. Then we've got our cubic function, which does go through 0, 0. And goes to 1, 5, and then 2, 2, and then 3, -3, which is a point of intersection, and then 4, -4, 5, 5, so something like that. So we've got, and that's kind of badly drawn on my part, but we've got 2 areas here. We've got 3 intersection points, so we're going to do pretty much the same thing we did on the previous problem. So if you feel like you've gotten the hang of this, you should definitely see how you do on your own, and then check back at the end with the answer. Our first area starts at 0 and goes to 3. Remember, we only care about the x values. The cubic function's on top on this left area that we've got, so we're going to do x cubed minus 7x squared plus 11x. And then we're going to subtract the x squared minus 4x from the parabola because of the parabola. Then we've got 3 to 5. It starts at 3 and ends up there at 5 for our x value. This time the parabola is on top, so it goes first. And we're going to subtract the cubic function. And again, after we add like terms, we should have the same thing for both of these, just with opposite signs for all of them. So this negative, when I distribute it, is going to give us negative x squared and positive 4x. So that's x cubed minus 8x squared plus 15x. And then 3 to 5. And you know, you can just write it down, or you may want to check to be sure. This is a good way to check to see if you added like terms right the first time. It is negative x cubed, and then x squared plus 7x squared is 8x squared, and then negative 4x minus 11x is negative 15x. So since those are opposite, that's a good sign. Let's power rule. Get x to the 4th over 4 minus 8x cubed over 3 plus 15x squared over 2 from 0 to 3. Then we've got negative x to the 4th over 4 plus 8x cubed over 3 minus 15x squared over 2. We're going to plug in 5 and 3. If you're plugging this in on your calculator, it may be that you don't need to actually write out the next step, but if your teacher does partial credit, which most math teachers do, then it may get you more credit to have it written out. It may not. It just depends on the teacher. But we want to do the 3 plugged in, and then the next part will be minus 0. And then we want to, this time we are out of luck a little bit because we're going to have to do 2 different ones on this one. Now notice that this is negative 5 to the 4th power, and the negative 5 should not be in parentheses. So don't put parentheses around positive numbers. You only put them around negative numbers, and you only put them around the negative and the number, not other stuff as well. So you have to be careful. And then we need to do 3 plugged in. And these problems can be very frustrating because they're pretty long and kind of tedious, and unfortunately that's the way life goes sometimes. So either plug this all into the calculator, or you can do try to do it by hand. And either way, it's not super pleasant. Like, I went ahead and powered through doing it by hand, but it did not go super well. I think it took me a while to get the right answer, which is 253 over 12. Which for some reason I did not write down the decimal on, so that's, I don't know, like 21 point something. 21 point something is the answer to that if you get the decimal. So that is area between 2 curves. Now we're going to talk about volume with disks. And so the thing with volume with disks is that we have to remember the formula to use, that you want to do pi and then your integral from a to b. A and b are going to come either from the problem or from intersection points or things like that, just like before. But we want to take what our function is and we want to square it. And so this is basically us doing like a pi r squared situation. That's where this squared comes from, is we're saying that our function is the radius, and so we need to square it to figure out the volume. So if I graph the cubed root of x, it's going to, start at 0, 0, and then 1, 1, and then at 8 we can do 2, and then we can also go this other direction. And so we want to be between our cubic function, y equals 0, and x equals 1. And so that gives us this little bitty little cute little region of revolution right here. And so what we're doing, and it says in the instructions, is we're rotating this around the x-axis. And so we're creating a three-dimensional shape. So our answer is not going to necessarily make sense as far as what the area of this would be, but it should be a possible volume of what this is if we think about it three-dimensionally. So when we set this up, we put the pi on the outside, and the pi is just going to hang out pretty much the whole time. Our boundaries are on the left 0 and on the right 1. And then we want to use our function, which is the cube root of x, and we want to square that. Now the cube root of x squared, if the cube root of x, or okay, so we've done the square root of x recently, and we said the square root of x was a 1/2 power. The cube root of x is a 1/3 power. And when I square something, I actually multiply the exponents together. Like if you do x to the third squared, you have x to the third twice, which is x to the 6th. You're multiplying these together. Same thing happens here. X to the 1/3 squared is x to the 2/3. So we're going to rewrite it as x to the 2/3 so that we can use the power rule. This is going to be add a power and divide, so we're going to have to add 3/3, which is 5/3, so x to the 5/3 over 5/3, and we're plugging in 1 and 0, and so that means that I can flip the 5/3 and make it be 3/5 x to the 5/3, which means it's 1 to the 5/3, or you can just leave it on the bottom and plug it in that way. When you plug in 0, 0 to any power is just 0. 1 to any power is 1, so this is going to end up being 3/5 pi. And so if you're in my class, we have seen this same question quite a few times. So if you have not yet figured out how to square x to the 1/3 or square a cube root of x, you should probably try to do that sometime soonish. Here's another one that we are rotating around the x-axis, and I've got y equals 0, x equals 2, and x equals 1/6 is the weird part of this. That's a line that's close to 0, but is not quite 0. So we want to graph 1 over x, and that will give us a reciprocal function. So the reason it's at 1/6 is because at 0, nothing is happening here. At 1, our function is at 1. At 2, it's at 1/2. At 1/6, that'd be at 6, actually, because 1 over 1/6 simplifies to be 1/6. And so we can actually kind of come up with a graph here. And if we drew on the rest of it, it would be not exactly like that, but it's down there. So what we want is this area, well, the volume. We're going to use this area and rotate it around. So we've got like a tornado on its side kind of thing going on. And because we're rotating around the x-axis. So we want to integrate from the x value they gave us 1/6 to the other x value they gave us 1/6. We want to square 1 over x. So 1 over x, when you square it, is just 1 over x squared, and so we will need to think about that like it's x to the -2, so that when we add a power and divide, we get x to the -1 over -1, which ends up giving us, when we simplify, -1 over x. That's what we're going to plug 2 and 1/6 in to. You don't actually have to move the x down to the bottom if you're plugging it into the calculator, as long as you plug it in correctly. This is -1/2 minus a negative. So that was cancel actually and give you plus. So this ends up being 11/2 pi. And I didn't write down the decimals on these. You could technically multiply out 11/2 pi, but in my personal opinion, that's a little silly to bother with because putting it with pi is fine. All right, 9. Now we are not rotating around the x-axis, we're rotating around a given axis. So in this case, we are rotating around y equals -1. And so that is also one of our boundaries, is y equals -1, as well as x equals 4. What we're going to end up doing is this -1 is going to add 1 to our function when we integrate. But when we're graphing, you want to graph this as is. You want to graph y equals the square root of x minus 1. And that minus 1 is outside with the square root, which is important. It makes it look very different. Well, not very different. It makes it look significantly different, though, if you don't put the negative 1 outside. So this is the function we're trying to rotate, and we're trying to rotate it around the line y equals negative 1. What we need to do is add 1 to this before we actually square our function. So this is going to be pi and the integral from 0 to 4 because we want our x values. And this is the square root of x minus 1 plus 1, which is really just the square root of x. We're going to square that. And since it's the square root of x and we're squaring it, and those are the same kind of power, like x to the 1/2 squared, if I multiply those together I get 1, that means that the square root gets canceled out. So we're really just doing pi 0 to 4 of x dx, which is pretty easy to do. We power rule, and then plug in 4 and 0. And so that's going to be actually just 8 pi, because when you plug in 0, you get 0. And so 4 squared over 2 is 8, so 8 pi. And again, if you multiply out 8 pi and you get 24, this area is not 24. What we're talking about is if I rotate this around, and you can look for pictures of how this works, but if we're saying that if we create this three-dimensional shape where we're rotating it around, that we're saying that volume is 8 pi, which, you know, is quite possible, I would hope, since that's the answer. Anyway, number 10, we're rotating around the line y equals 2, and that's also one of our boundaries. We're going to graph this, which starts at 3 and then goes down 1 each direction. So we've got a parabola here. So our shaded region is what's in between, our parabola and y equals 2, which means that our boundaries are -1 and +1. They didn't tell us our boundaries by giving us equations, so we had to say, okay, where are we intersecting? We're rotating around this line y equals 2, which means we're going to do the opposite of +2 and subtract 2. So I don't know if I said that on number 9, but whatever this is, you're going to do the opposite to your equation. So that means that this is really going to be -x squared plus 1. And we are going to square that, which means that we need to FOIL this out. If you put x to the 4th plus 1, you're almost right, but there is more to it. There's a middle term here because we're doing -x squared plus 1 times itself. And so there's an outer and inner -x squared and -x squared, which together give you -2x squared. So make sure you remember that. And then we will go ahead and integrate. So that gives us x to the 5th over 5 minus 2x cubed over 3 plus x from -1 to 1. So we'll plug those in. And when you plug in your -1, it may not matter a whole lot that you put it in parentheses, but it is on this one because all of our powers are odd. But it still is a good idea just to make sure that the calculator knows what you want it to do. If you either do this by hand or if you plug it in, which by hand there's lots of nice common denominators up to a point, we should get 16/15 pi. For our answer. So that's volume with discs. Let's do volume with washers. Now washers kind of combine what we just did with volume and what we did before with area between curves, because we have a formula this time that is the outer function squared minus the inner function squared. And so it's kind of like top and bottom, and most of the time if you think of it like top and bottom, you'll be fine. There will be a problem on here later on that has kind of an issue to it because it's not top and bottom, it's actually bottom and top, but we'll get to that later. So we want to graph these two equations. Sorry, I couldn't find my cursor. We want to start at 1, then go this way. That's our square root function. And then we've got a parabola that starts at 1 and goes up. And so this is where you gotta kind of, that's not the best parabola, but you gotta pay attention to what's on top and bottom here, or what's on the outside and the inside, because we're rotating around the x-axis. It says so in our instructions. And so that means we want the outside of this, which is our square root function, to go first. And we're between 0 and 1. So we want the square root function to go first. And then we want the parabola to go second, because the parabola is the underneath part of this. And we are squaring these separately. Unfortunately, both of these require us to FOIL. They don't just naturally cancel out the square roots on this first one, which may make you sad, but that, you know, we don't always cancel square roots out in life. That's just not a thing. So whenever I FOIL this out and do square root of x times the square root of x, I get x. When I do the outer and inner term, I get square root of x both times, which gives me 2 square roots of x. And then I do 1 times 1, which gives me 1. Then I'm going to FOIL this out, so I have x squared and x squared. And then I do x squared and 1, which gives me 2x squared. And then I do 1 times 1, which is 1. And then I can add like terms if I have any here. So there's not a whole lot. If I want to put this in order, I'd put negative x to the 4th and then negative 2x squared together. The 1's actually cancel because I have 1 minus 1, so that's nice. And then I have plus x and plus 2 square roots of x. And I'm going to go ahead and change 2 square roots of x to 2x to the 1/2 to save myself an extra step of writing. And then I'm ready to power rule this. So the power rule is going to give me negative x to the 5th over 5 minus 2x cubed over 3 plus x squared over 2 plus, and this is a fraction, so we're going to add 2 over 2 and get 3/2 and then divide by 3/2 and then plug in 1 and 0. So the 0 part of that is going to end up being 0. We really just need to plug in 1, which of things to plug in, that's usually something that's not too terribly difficult, either by hand or on your calculator, like compared to other things. Here you can leave it as 2 over 3/2 if you're putting it in the calculator, or if you want to simplify it, you flip the 3/2 and get 2/3. So 2 times 2/3 is 4/3. And so we just need to work out what this is, either, like I said, either by hand or on the calculator. We get 29/30ths when we do this with a pi, and so that is our answer. All right, volume with washers again. So we've already got our 2 x value lines set up, so we just need to graph this parabola, negative x squared plus 4, which starts up here and goes down both directions. And what we're really going to care about is what's in between those blue lines. So it's a very small place right there. Wow. So, you know. And then x plus 2, which is a line that starts at 2 and goes up 1 over 1, or down 1, left 1, which is actually what we care about, because we want this area that's in between negative 2 and negative 1, our line and our parabola. So we've got pi, we are between negative 2 and negative 1. Our outside function is the one on top, because it's outside, it's the one farther from our axis of rotation is the parabola. So that's going to be negative x squared plus 4 squared minus our other function, which is x plus 2, which is the one that's closer to our axis. And so we're going to FOIL this all out and then power rule. So if you did okay on the last one, you can try this and see if it goes okay for you. And then just look at the answer at the end. So this is x to the fourth. We have negative 4x squared and negative 4x squared, which is negative 8x squared, and then plus 16. And then we're going to minus, and this should be easy to FOIL because it's just x plus 2, x squared plus 4x plus 4. We want to add like terms. We don't have to. Like, you can just go straight to the power rule if you want to. It's, you know, it's kind of whatever. It may or may not save you time to add like terms. So we do x to the fourth. Negative 8x squared minus x squared is negative 9x squared. And then we would put minus 4x. And then 16 minus 4 is plus 12. Then we're going to power rule this. So that we get x to the fifth over 5 minus 9x cubed over 3, which does simplify, as well as negative 4x squared over 2, which simplifies, plus 12x, which I should not have put that there. I should have put it over here, because now we don't have the integral anymore because we used the power rule. So we're going to plug in negative 1, we're going to plug in negative 2, and you can write it all out, or you can just plug it into your calculator, or you can work it out as you go. If you do it correctly, you should get 16 fifths pi, I believe. So work it out, see if that's what you get. That should be the answer. The last two problems we're going to do is volume with washers, but this time we are not rotating around the x-axis, we're rotating around some other x-axis, and this is going to work similarly to what we did with discs, where we have to add or subtract. Again, you want to draw it as is, so like y equals negative 3. Oh, I'm going to have to draw that. Is down here. And then we've got square root of x minus 3, so we start at negative 3 and go up and over like so. And so we're talking about this little bitty piece right here. Now this is what I'm talking about as far as outside minus inside, although it actually is a little bit more complicated than that even, because we want the radius basically of what's happening here. So how far is it from this line where I'm rotating around? How far is it from that line to get all the way to this outside, which is at y equals negative 3? That's actually a distance of 5. And so that's what our first radius is it's 5 the whole way across, but it should actually be 5. So that's 5 squared. We're going to subtract the radius that's closer, which, if we look at it, it's this part right here that leads up to our square root function. So then what would that be? If we use our trick from before where we said if this is a plus 2, we would subtract 2 here. We get the square root of x minus 5. But what's happening is we're also like flipping this. So this is really like having 5 minus the square root of x. And so if you don't do it that way, like I actually worked this out the first time not realizing that I needed to switch signs. And so I worked it out as negative 5 squared minus square root of x minus 5 squared. And I got the right answer just with a negative. And so that is one way to do it, is to just say I'm going to subtract 2 from both of these. The outside is the negative 5. The inside is the square root of x minus 5. And then if you get a negative answer, switch it to positive and you should be good to go. So these will give us the same thing. To sum up, these will give us the same thing just with opposite signs. And so whichever way you want to do it is fine. If I do it this first way, since it has less negatives, I would get 25 minus, I'm going to square these, so 25 minus 10 square roots of x plus x. dx. Hey Derby, can you plug my computer in by you real quick? Do you see it? So I can add like terms, which is basically going to cancel these 25s out, and then I need to distribute the negative inside of this. So this is pi 0 to 1. It'll be positive 10 square root of x, or positive 10x to the 1/2, and then distribute the negative and get minus x. And so we'll add a power and divide. So 10x to the 3/2 over 3/2 minus x squared over 2. We're going to plug in 1 and 0. If you plug in 1, which should be pretty easy, and then it doesn't, the 0 part of that doesn't really matter since it's 0, you should end up with 37/6 pi. And again, if you do it that other way, because you don't realize that, you know, technically we're supposed to switch the signs, you'll get negative 37/6, and then you have to say, well, volume shouldn't really be negative, so it must mean that I need to just switch the sign. And that has to do with it being below where we're rotating. As long as what we're rotating is above, then we should be fine to just do top minus bottom. Whenever it's below, it gets a little bit trickier than that, so you have to think about the outside minus the inside and see what happens. But 14 is going to be up at the top, or up above, and so this one's going to be easier. We've got all the lines drawn. I believe we're rotating around y equals -1. We just need to draw this parabola, which starts at 2 and goes down 1 each direction. And so since we're trying to be between 0 and 1 for x and 1 in this parabola, this is our little bitty region that we're rotating. We're rotating it around this line down here. So if you actually think of this perspective-wise, that would rotate to this right here. So we would have like this hole in the middle and then an outside region. We want to do the integral from 0 to 1. We want to do the outside function, which is our parabola, minus our inside function, which is 1. We're going to square and get x to the 4th minus 4x squared plus 4 minus 1. Oh wait, I didn't add the axis. So let's pretend that didn't happen, and let's go back and add it in. Because this was -1, I need to add 1 to this and put 3, and I need to add 1 to this, which is 2. So that this would be from 0 to 1, x to the 4th minus 6x squared plus 9 minus 2. Let me make sure that that is right. Yeah, okay. So now I can put those together and get, okay, I didn't square the 2, that'd be 4. I can put those together and get 5. So I power rule. And plug in 1 and 0. Again, that shouldn't be super tricky. So you should get an answer of 16/5, which we actually got on an answer earlier. Weird, go figure, but that is our answer. So that is all of the review. Have fun.